Okay, in this video, we're going to start talking about solving trigonometric equations. This is found in 6.5 in the textbook. This is part 1. All right, in these examples, we're going to be using special angles and special values. So you may want to find your unit circle from notes a little while ago to help you with this, though in general you don't want to always just look at a unit circle that's already filled out. You need to be able to come up with it yourself. Now, there's different directions that will come with trig equations. Sometimes they say to solve the equation in the interval from 0 to 2 pi. This is a common interval. Notice there's a square bracket with the 0, so 0 could possibly be a solution. With 2 pi, there's a parenthesis, so you would not use 2 pi. So basically, you're looking at your unit circle and you're finding any positive answer within one full rotation. So this does translate to find all values of whatever your variable is, and we'll be using theta to satisfy each equation so that theta is between 0 and 2 pi. Okay, here's our first example. Solve the sine of theta equals 1/2. Okay, so you want to find all the angles so that their sine value is 1/2. So if you go back to the unit circle at the beginning, you'd be looking for any of the points where the y coordinate is equal to 1/2. So that would bring you to this point right here. The y coordinate is 1/2. And this angle would be pi over 6. And then also, if you go straight across the y-axis, this point also has a y coordinate of 1/2. Okay, as far as y coordinates go, you're looking at the y-axis. Here, y is 0, and at the very top, y is 1, because we're doing a unit circle, and this radius is 1. So if you look about halfway, those are going to be the 2 points where the y coordinates are 1/2. So one of the angles, like I said, would be pi over 6. The other one over here would be 5 pi over 6. So the answer to this is theta would be pi over 6 or 5 pi over 6. All right. Now, a lot of times when I'm visualizing this problem, I draw what I call sloppy little circles, and I'm like, okay, here's a solution and there's a solution. And that's how I picture it. All right. They're reflections across the y-axis because you're dealing with sine. Okay, here's another one. Solve the cosine of theta is equal to the negative square root of 2 over 2. All right, so you have to know that that's a special value. If you go back to the unit circle, the point here in the middle of the first quadrant, its x coordinate, oops, I'm sorry, it's negative root 2 over 2. Okay, so not there. Over here in the middle of the second quadrant, the x coordinate is negative root 2 over 2. So this angle right here, which is going to be 3 pi over 4. And then also directly below it, reflecting on the other side of the x-axis, the x coordinate will also be negative root 2 over 2. And so that angle is 5 pi over 4. So we have two solutions. Theta could be 3 pi over 4, or it could be 5 pi over 4. Again, if you were just drawing your own circle and doing it from memory, you come up with a place in the middle of the third quadrant. And then directly below that, in the middle of the second quadrant and in the middle of the third quadrant. 3 pi over 4 and 5 pi over 4. Okay, this problem has tangent. Here you want to find out where the tangent of theta is equal to root 3 or the square root of 3. Okay, so if we go to our unit circle, now that's not going to be directly one of the coordinates. The tangent is the y coordinate divided by the x coordinate. And we did talk about tangent values. If you start at 0, the tangent is 0. The first special point up, it's going to be root 3 over 3. In the middle of the first quadrant, it's 1. And then going up higher, it'll be exactly root 3. At the very top, tangent is undefined. Right? If you keep going around, it repeats the pattern. It changes signs. All right, so here at 2 pi over 3, it would be negative root 3. In the middle of the second quadrant, it's negative 1. Then it's negative root 3 over 3. Here it's 0 again. Then it's going to be positive root 3 over 3, positive 1, positive root 3. It's undefined. And then it's going to be root 3, negative. I'm trying to do this too fast. And then negative 1, then negative root 3 over 3. Okay, so those are the common tangent values. So if you're trying to find where the tangent of theta is equal to root 3, then you're talking at the very top of the circle. Well, almost the very top. The very, very top, the tangent's going to be undefined. So that's where the tangent would be root 3. That angle is pi over 3. That's going to be one answer. For tangent, to get another place with the same tangent, you go directly across the circle. So it's kind of sloppy, but it'll be right down here at 4 pi over 3. It's a reflection across the origin. Okay, this problem here, you're asked to find where the cosecant of theta is equal to negative 2 root 3 over 3. All right, so the best thing to do when you've got it in terms of cosecant is use the reciprocal. So the reciprocal of cosecant is sine, and then do the reciprocal of whatever the number is. So if you flip that one upside down, you're going to have 3 over negative 2 root 3. Which doesn't look familiar, but if you rationalize it, it will be. All right, so this would be 3 root 3 over negative 6. And then if you simplify, you're looking for where the sine is equal to the negative square root of 3 divided by 2. And then on the unit circle, those are going to be places down near the very bottom. Not the lowest, but the ones closest to it, the special angles, here and here. So we're talking at 4 pi over 3 and 5 pi over 3. All right. Now, let's just briefly talk about, they might ask you to solve in the interval from 0 degrees to 360 degrees. Practically the same thing as what we were doing. We were working in radians, now this is in degrees. So where is the secant of theta equal to negative 1? Again, it's easier to work with secant thinking of it in terms of cosine. So if you do the reciprocal of secant, you're talking about the cosine of theta, and then you do the reciprocal of negative 1, which works out to be the same number, negative 1. All right, where is the cosine equal to negative 1? That's at the far left. The point there, the x coordinate is negative 1. And so that angle is, well, I was going to say pi, but we're doing degrees. So we're going to call that 180 degrees. So that would be the answer to this one, 180 degrees. Okay, one last one. This one says to solve 2 times the sine of theta plus 1 equals 0. All right, now this is the first one that we've looked at where it's not solved for the trig function itself. This has other complicated things in it. It has where you're multiplying by a 2 and you are adding 1. What you need to do first is isolate the trig function. We need to isolate that. Okay, so the way to do that would be to subtract 1 from both sides. So you'll have 2 times the sine of theta is equal to negative 1. And then you'll divide by 2. So this tells us where we want to find where does the sine of theta equal negative 1/2. Okay, that is going to happen places below the x-axis, since that's where a y-coordinate would be negative. Negative 1/2, it's going to happen here and here. The ones kind of closest to the x-axis, but underneath. Like if here's your 3 points, it'll happen here and there. All right, so we're talking at 7 pi over 6 and also 11 pi over 6.